Good morning, friends. We'll start API 502. So, what is the essential to quality and effectiveness of RBI evaluation? Identification of appropriate deterioration mechanism, susceptibilities, and failure modes for all equipments included in a RBI study. Which of the following need to be considered during RBI evaluation? Process conditions as well as anticipated process changes. What are the primary inputs to the probability of failure evaluation? Deterioration mechanism, rates of susceptibilities. Dash is a key input of determining the consequences of failure except when a worst case consequences analysis, assuming total release of component inventory is used. Failure mode. APRP 580 is concerned with one type of failure, namely loss of containment caused by deterioration. Whichever one of the following is a deterioration mechanism observed in the hydrocarbon and chemical process industry? All of the above: thinning, stress corrosion cracking, metallurgical and environmental, mechanical, all of the above. What are key to performing deterioration mechanism identification, understanding equipment operation, and in interaction with chemical and mechanical environments? Process specialist can provide useful input to aid material specialist in the identification of deterioration mechanism and rates. Effect of thinning can be determined from thickness, equipment age, corrosion rate, corrosion allowance, operating pressure and temperature, design pressure, all of the above. SCC occurs when the equipment is exposed to environment conducting the cracking mechanism like caustic cracking, amine cracking, sulfide stress cracking, HICs, SOHIC, all of the above. Stress corrosion cracking. Fabrication variables such as post-weld heat treatment, PWST, can affect susceptibility to SCC. True. Determination of susceptibility to SCC should not only consider the susceptibility of the equipment piping to cracking, but also the probability of crack resulting in leak or rupture. One example of metallurgical and environmental failure is high temperature hydrogen attack in carbon and low alloy steel. Nelson curves are maintained based on industry experience in APRP 941. Consideration of equipment susceptibility to HTHA is based on material of construction, operating pressure, H2 partial pressure, operating temperature, and exposure time, all of the above. The most common mechanical deterioration mechanism are fatigue, stress, grip rupture, and tensile overload. RBI could be expanded to include failures other than loss of containment. Example of such failure: pressure relief device failure, heat exchanger bundle tube failure, leaks, whole dismemberment of internal fit linings, Deterioration mechanisms are not the only cause of loss of containment. Example of other cause is seismic activity, operator error, overpressure due to failure of pressure relief device. A qualitative method for probability of failure analysis involves identification of the unit, system or equipment, material of construction, and corrosive components of the process. True. Future inspection and maintenance plans, possible material deterioration, probability of failure can be assessed separately for each unit, system, equipment grouping, or individual equipment items on the basis of knowledge and operating history. In quantitative probability analysis, the probability may be expressed as distribution rather than a single determined value. When inaccurate or insufficient failure data exists on the specific item of interest, general industry, company, or manufacturer failure data are used. Regardless of whether a more qualitative or quantitative analysis is used, the probability of failure is determined by deterioration mechanisms, rates of equipment, item, material, and cost of construction resulting from operating environment, effectiveness of inspection program to identify and monitor the deterioration mechanism so that the equipment can be repaired or replaced prior to failure. Analyzing the effect of in-service deterioration in inspection, probability of failure involves all of the above. Identifying active and credible deterioration mechanism that is reasonably expected to occur during the period of being considered, determining deterioration susceptibility and rate, quantifying the effectiveness of past inspection maintenance program and the proposed future inspection and maintenance program, determining the probability that with the current condition continued deterioration at the expected rate will exceed the damage tolerance and result in a failure. The ability to state the rate of deterioration precisely is affected by equipment complexity and type of deterioration mechanism, process and metallurgical variations, inaccessibility for inspection, limitation of inspection, test methods, and inspector expertise. Sources of deterioration rate information include published data, laboratory testing, inside testing, and service monitoring, experience with similar equipment, previous inspection data, all of the above. Other sources of information on deterioration are database, plant experience, or reliance on expert opinion. Which of the following is not true? General thinning from corrosion often leads to small leaks. Heating generally leads to small hole-sized leaks. SCC can develop into small through-wall cracks or some cases catastrophic failure. Metallurgical deterioration and mechanical deterioration can lead to failure modes that vary from small holes to rupture. All these are three are true. This is not, last one is not true. After likely deterioration mechanisms have been identified, the inspection program should be evaluated to determine the effectiveness of finding the identified mechanism. Limitation in the effectiveness of an inspection program could be due to lack of coverage of an area subjected to deterioration, inherent limitations of some inspection methods to detect the quantify certain types of deterioration, selection of inappropriate inspection method and tools, all of the above. If multiple inspections have been performed, it is important to recognize that the most recent inspection may reflect current operating conditions. Determination of inspection effectiveness should consider equipment type, active and credible deterioration mechanism, and RET ND methods coverage and frequency, accessibility to expected deterioration areas, all of the above. The consequence analysis in the RBI program is performed to provide discrimination between equipment items on the basis of significance of a potential failure. For a user, consequence analysis is the aid in establishing a relative risk ranking of equipment items. The consequence effects of loss of containment can be generally considered to be safety and health impact, environmental impact, production losses, maintenance and construction losses, all of the above. Functional failures other than loss of containment should include functional or mechanical failure of internal components of pressure equipment, heat exchanger tube failure, pressure relief device failure, rotating equipment failure, all of the above, other than loss of containment. The other functional failures are usually covered within RCM and therefore not covered in API 580. Quantitative and qualitative approaches of consequences analysis are endpoint of a continuum. The other functional failure are usually covered within RCM and therefore not covered in API 580. Qualitative and quantitative approaches of consequence analysis are endpoints of continuum. Quantitative models calculate consequence of failure on type of process of fluid in the equipment, process temperature and pressure, state of process fluid in the equipment, all of the above. Failure mode and resulting leak size are few of the factors to be considered to calculate consequences of failure using quantitative models. True state of fluid that release the ambient condition in a factor of to be considered to calculate the consequences of failure using quantitative models. True. Safety consequences may be expressed based on the severity of injury like fatality and medical treatment. In order to rank consequences according to affected area, it is typically assumed that equipment or personnel at risk are evenly distributed throughout the unit. State of fluid after release in ambient condition is a factor of considered calculate the consequences of failure using quantitative models. True. Specific consequence may be expressed based on severity of an injury like in order to rank consequences according to a affected area, it is typically assumed that equipment or personnel at risk are evenly distributed throughout the unit. Environmental consequence measures are least developed measures along those currently used in the RBI. Typical parameters that provide the indirect method of degree of environmental damage is acres of land affected per year, miles of shoreline affected per year, no number of biological or human use resources consumed. So all of the above. Most of consequences evaluation, a key element in the determining magnitude of consequences, volume of fluid released. In all cases, volume released will be same as volume available for release. False. Which of the following are not typical categories of fire and explosion events? Sabotage. Toxic releases in RBI are only addressed when it affect the personnel. While considering consequences due to toxic release, RBI program typically focus on acute toxic risks that create an immediate danger. Generally, consequences release other hazardous fluid is significantly lower than flammable or toxic releases. So lower than flammable or toxic releases. When considering the environmental consequences, RBI program typically focus on acute and immediate environmental risks. The main production consequences of RBI are when considering the environmental consequences, RBI program typically focus on acute and immediate environmental risks. The main production consequences of RBI are financial. Business interruption consequences process unit daily value into downtime in days. Dow fire and explosion index is a typical method of estimating the downtime after the fire or explosion. Loss of containment failure may only be the first event in a series of events that lead to a consequence. The probability of specific consequences is tied to the severity of consequence and may differ considerably from probability of equipment failure itself. Loss of containment failure may only be the first event in series of events that lead to a consequence. The severity of the probability of specific consequences is tied to the severity of consequence and may differ considerably from probability of the equipment failure itself. Probability of incident is generally decreased with severity of incident. Personal inexperience in risk assessment methods often link the probability of failure with most severe consequences that can be envisioned. Probability of specific consequence is the product of the probability of each event leading up to the specific consequence. Okay, we'll stop here.